The first talk is from Unified Streaming, and it's dealing with live media ingest. So, Rufael?
Hello, everyone. Thank you to Yasser and Ali for organizing. My name is Rufael Mekuria. I'm with Unified Streaming, and I'm going to give some update on the live media ingest specification, which is a work done in the Dash Industry Forum. So I'm happy to present it here, and I just also want to acknowledge all the contributors of the Dash-IF Ingest Task Force that have also contributed to this work. So let's hit it off. So for those of you that have been involved with building large-scale streaming platforms, you know there are quite a lot of moving parts. I've listed them here. All of them are important. And if you are building such platform as a content owner or infrastructure owner, you will find out sometimes that interop between them is also important. So standardization is more than just a player format. So in this Dash-IF Ingest Task Force, we try to mainly standardize the live encoder output, but also the content ingest to the CDN and to the packagers. So here's an example of a large-scale live OTT streaming workflow. So you'll often have the media source that can be a broadcast signal, a TS, or a SDI signal, and it goes to the live ABR encoder, which produces the adaptively encoded bitrate tracks, which are then often pushed to an origin server or a packager that in its turn uses the CDN to distribute the content to the player. So one important interface is between the live ABR encoder and the origin server, and also between the packager and the CDN, or the live encoder and the CDN. So in the Dash-IF Ingest Task Force, the goal was to bring some of the important players in the industry together and to define these two interoperability points and write down the specification, which is currently under the community review. It's open for feedback, so it can be found under this link that you see underneath. So why a new protocol for live ingest in OTT? So the often used RTMP and Smooth are becoming deprecated because some new features, some new content features that are becoming available are not supported formally in these protocols. And then FMP4 and CMAF, which are becoming now the dominant segment format in OTT. So if you're using HLS or Dash or smooth streaming, the segment format can be based on CMAF. So using CMAF as an ingest makes sense. And then another aspect is that the push-based Dash and HLS, many live encoders, they push Dash as an output or HLS as an output. But how to do this is not well specified, so that motivated this work to write it down. And then what we hope to achieve with this specification is to have a good time metadata in OTT, to be able to signal content splice information properly, and then also to have this fault tolerance, low latency, redundancy for large-scale streaming, and just to document the best practices and have some industry convergence around that. So just to highlight a bit the difference with the push-based and pull-based. So in push-based, the source initiates the connection, the transfer, basically an HTTP post. While in pull-based, the receiver typically initiates the transfer by doing an HTTP GET request. So Dash and HLS are both pull-based protocols to deal with the scale. However, most live encoders, they do push-based to just push the content that they generated to an origin or a smart server to take care of the delivery. That could be packaging or streaming or CDN functionalities. So that's where push-based comes around. But how to do push-based Dash or CMAF is not well defined. So that's where this specification comes in. So the project was started, and we had quite some support from some of the companies in the industry. What I especially like is that we had, for each of the sort of components, we had several companies represented. So these companies supported the work, and later also other companies also helped in contributing to the specification to make it accurate and technically concise. So this is sort of the timeline of this project. So it started in 2017 as an interop with Elemental, BBC, Unified, Media Excel, and to define some way, like what should a live encoder output. It was mainly a question that came from the BBC. Then in 2018 there was an informal IETF draft to document this, and then that gained some momentum, and then this -IF task force was created. And at the beginning of this month, the document was ready for community review, and now it's targeted for publication in the end of August. So the specification has two interfaces defined. One is CMAF ingest, and one is Dash or HLS ingest. So in the first, we just basically only use CMAF and HTTP post, and in the second one, it's basically a post or HTTP put version of Dash and HLS. In a workflow, it's possible that a live encoder produces the CMAF ingest to a packager, and then the packager may post to a CDN in some workflows. So I will go a bit more into detail into the CMAF ingest, which is so the Dash and HLS ingest is already common, but the CMAF ingest, it seems that it's a bit more innovation in there, so I would like to emphasize a bit. So the main idea is to basically post each CMAF track to the origin or to the packager. It could either be a long-running post or a short-running post. And then, for example, if you use the HTTP chunk transfer encoding, you can just have a long-running post and post each of the media objects in CMAF to the origin. So basically what we have is we have CMAF tracks with video, audio, time text, time metadata, one TCP connection per track. And what's important is to have this continuity between the fragments. So this way, when you are archiving the ingested streams, it will still be a valid CMAF or FMP4 file. And then what's also compared to those of you who probably work with smooth ingest, live encoders, this specification then also has the new optional boxes introduced in CMAF. So here's an example of a CMAF track that could be ingested. So for those of you that work with live encoders that supported the smooth ingest, it's important to note that in the case of CMAF ingest, we only use standardized boxes. So basically these boxes are defined either in CMAF, in Dash, or in the ISO-based media file format, which are all ISO standards. So in these boxes cannot just be changed, for example, if Microsoft wants to change a box in the smooth streaming specification. Another advantage to this, hacking in some of the previous talk, is that it will be many of the new technologies like AV1 or VVC are developing bindings for CMAF. So by ingesting CMAF, we can also, it will be more easy to use these new codecs or new features. Then there are also some new boxes in CMAF. So what you basically see in CMAF is you have the CMAF header, which is basically a combination of a file type and a movie box, and then the fragments, which can be move.m.dot boxes. But there are also some new boxes like the Dash event message box. So these can also be sent. So for supporting CMAF ingest, some new boxes also should be taken into account, which were not so much used before. So PRFT can be used to signal additional timestamps, while the Dash event message box can be used to send time metadata. So then the protocol also looked at the security and network considerations. So based on requirements from content owners, we made it mandatory to use HTTPS, or at least strongly recommended, and then basic authentication is supported. In the future also we will look at some forms token-based authentication, but for now this is not in the specification. We harmonize the error response codes between the Dash and HLS ingest and CMAF ingest. And basically we harmonize the behavior so that the two interfaces are as similar as possible. But most importantly, the protocol is kept simple, so it's basically posting CMAF fragments and chunks to the receiving side. Then another question that came up is how to signal switching sets. So switching sets are basically groups of tracks that can be used for switching. So also for this, we use the CMAF specification. So if you read the CMAF specification, there are certain constraints on switching sets, and given that we post one channel or one content to one URI or one publishing point, the receiver can basically look at the header, and if the tracks have identical headers, they belong to the same switching set, not exactly the same header, but if they fulfill the constraints as defined in CMAF, as outlined here. So basically you can iterate over the boxes in the header, and when these constraints are fulfilled, you can know that tracks are belonging to the same switching set, given that the fragments are also, the fragment boundaries are also aligned. So then another aspect that is covered in CMAF ingest is the use of redundant live sources and failover behavior. So with CMAF ingest, because we're just only sending fragments with clearly GOPs with clearly defined boundaries, we can do a dual ingest. And then also in case a live source fails or a receiver fails, there are some procedures defined for how you can restart an instance, for example, in a cloud deployment to continue the streaming. So this solves some of the problems with, for example, with HLS ingest, with sequence numbering that is not matching between different live sources. So a big advantage of CMAF ingest is this, besides the other advantages, is that it's easier to achieve redundant setups. So then another important aspect that is novel in the CMAF ingest is the time metadata track. So to support just-in-time packaging, we send the time metadata in separate tracks. So these tracks use dash event message boxes, which can encapsulate the time metadata, which can be SCOTI35 or ID3, or in some cases also other metadata. So we define to use binary SCOTI35 embedded in dash event message box, or ID3 embedded in dash event message box as defined by Microsoft and Apple. The format of the time metadata track is a separate track. So if you look at CMAF, you will see that the dash event message boxes are top-level boxes embedded with the media data. For the CMAF ingest, we use a separate track because it's much lighter to process. And also we embed the dash event message box as samples. This way we can have the functionality from MP4 files for seeking and fragmenting. This basically makes it easier to scan the files so that a receiver can quickly find the metadata and generate the manifest or other things that are needed, or embed top-level event message boxes. So this time metadata track is currently a technology under consideration in MPEG and in CMAF. So basically that means it's in an early stage of becoming standardized in case there is sufficient support for this metadata track. So here's some example of what it might look like. In this case, we have a fragmented time metadata track. So again, we have the same structure with the CMAF header and the CMAF fragments. But in this case, samples in the fragments may contain dash event message boxes, which then encapsulate the metadata. So in this case, if you have multiple events at the same time, you need to encapsulate multiple dash event message boxes in the same sample. And also a fragment could, for example, contain multiple samples containing multiple dash event message boxes. But by having this fragmented structure, we can use the same transmission method as for the media data by just posting the fragments to the origin server. All right, so now I come to the second interface, which I will only give a very high-level summary of. So basically Dash and HLS ingest. So what you do here is that you basically post the manifest and then you post each of the segments in the different representations to different relative URI path that correspond to what was given in the manifest. So this way you can have an origin or a CDN node which is very lightweight and very simple. All it needs to do is to store the content that's coming in and make it available at the web server via HTTP GET. So this is supported today in many live encoders, but it's poorly documented in specification. So the main contribution of -if live ingest is to basically write down some of the procedures. Some of the important things that are defined is naming. So basically the MIME type of the file extension. This way the CDN can detect what type of segments are there. Another thing is the uniqueness of the segment. So basically you need to add numbering or timestamps to the segment names because the origin or CDN needs unique segments in each presentation in order to identify duplicate segments or not. So then there is a third option. So maybe some of you know that HLS already has some support for having CMAF as a file format, while in Dash currently there is a binding for CMAF underway. So another idea is to basically combine the interface 2 that I previously described, where you're basically posting the manifest and the fragments with CMAF. And in this case, you could create an interface that supports both the CMAF ingest and the Dash HLS ingest. So with this interface, you may be able to push to an origin that just stores it and makes it available as an HTTP GET, or to a node that does a repackaging. So one of the important things of CMAF is that all the properties of the media are well defined. In CMAF ingest, we also did some work to check that each of the properties that you need to create a manifest are there. So one example where we added some things based on CMAF is the accessibility properties. So for example, if you have subtitle track, time text track, you have the properties of accessibility. So basically we use the roles defined in MPEG Dash and we signal them in the kind box just to be sure that the packager can detect the roles of each of the tracks and generate the manifest correctly. So this is still under consideration, but this might be another interesting sort of mezzanine format to support for the industry, some format to feed to packagers or to basic cloud storage nodes for storing content. So just to give a brief summary, so we aim to harmonize the encoder output and the ingest to CDNs or origin servers. We think this is important, especially with the CMAF binding. We can have a faster adoption of new technologies like HEVC, VVC, different encryption in streaming workflows. The -if live ingest defines both a CMAF ingest without a manifest and a -HLS ingest that includes a manifest. The activity also defined a time metadata track to enable fast processing for just-in-time packaging. And then also procedures for security, fault tolerance, and redundancy are defined to enable these large-scale streaming workflows that you need to target millions of users. And then there is the idea of combining the two into a CMAF plus -HLS interface. All right, so the document is available in the -if GitHub. We also started some work on some reference software. It's available under this link. Basically, it's a tool for ingesting CMAF files to an origin server using the -if live media ingest protocol, interface 1 CMAF ingest. So you can check it out. It's a C++ code. And there's also a demo available where we basically use Docker Compose and different Docker containers. So one Docker container contains some example CMAF files, and it posts them using the reference software to an origin. In this case, it is the origin that developed by Unified Streaming. And that shows basically that from a single set of CMAF files, you can stream Dash, HLS, Smooth, and different encryption methods, what your platform needs. So the next steps, so the document is currently under the community review, which means there is still some openness for comments from the wider community, from other standards bodies, but also from people like you who are working in a practical video streaming platform development. Then we're working hard with live encoders to implement the protocol. So several live encoders already implemented the CMAF ingest, and some of them also implemented the Dash HLS ingest. And then as you saw, we are working on the test vector reference software. And then in a later stage, it also needs to go for formal standardization. So initially we will publish it as a -IF document. But once there is a good sort of industry support for this, we can also standardize it as an ETSI specification or perhaps an MPEG specification. This is not yet decided. So the URI to the project is also given. So that was my presentation. I want to thank you for your attention, and I want to open the floor for questions.
Okay, thank you, Rufael. We have time for a couple of questions. Are there any questions up in the audience? And if I can get the next speaker to be ready down over here, that would be good. Okay, I see one in the far back.
Thanks for walking all the way over here. Which encoders are implementing it or have? Can you say that?
This is recorded. I recommend you to maybe wait for IBC or
okay.
Yeah.
Any general types of questions that people want to bring up to Rufael? Okay, well, I have one. Can you talk a bit more about the any details on chunking and what new aspects might be coming in for that in terms of CMAF?
Yes. Are you referring to chunked CMAF?
Chunk CMAF.
Yes, the favorite topic of everyone today. No, that's supported because it's basically we ingest CMAF, and in that presentation I talk about CMAF fragments, but these could also be CMAF chunks. So in -IF live ingest task force, there was some discussion on whether you should use this S-type box to signal whether you're sending a chunk or a fragment. The opinion of some of the experts was that a smart origin that uses the CMAF ingest, they can detect whether it's a fragment or a chunk from the movie fragment header itself. So intrinsically, so if you read the specification, basically chunked CMAF is recommended for low latency. So if you want to do a low latency, large-scale streaming, you can ingest chunked CMAF, and then a smart origin could output also low latency Dash, for example. So it's basically, by using CMAF, we inherit a lot of the properties and the work that's going on CMAF in MPEG, but also, for example, CTA Wave, which are doing bindings of technologies that are not ISO technologies. So basically, yeah, we benefit from that, and the chunk transfer. The chunk CMAF is one of them.
Thank you. Other questions in the audience?
Yeah.
Wow, quiet audience here.
Yeah, so maybe if people are interested in which live encoders support this, you can also maybe send me a personal email about this, then we can check on that. Yes?
Okay, thank you again.